Hello students, welcome to another session of online class. Today our discussion is about transformations, that is called two variable transformation or joint transformation or bivariate transformation. So we'll discuss about that today. Our objective of today's class is like revising what we have studied in the last class and what is a bivariate transformation, how to find the mean and variance of bivariate transform. Also we have to discuss about the covariance of by transformed variable and correlation coefficient of the transformed variable. Also we will discuss a problem regarding this one. So revising the last class topics, we have studied that covariance exists between two variables. Covariance of xy is expectation of xy minus mean of x into mean of y. Correlation is defined as correlation coefficient is defined as rho of xy or rho xy is covariance of xy divided by standard deviation of x into standard deviation of y. These two equations are very important. From this one we can whatever things we are studying in the next classes depends on these equations. So remember these two equations. Simply covariance of xy is expectation of xy minus mu x mu y, and correlation coefficient is covariance divided by product of standard deviations. Two random variables are uncorrelated if covariance of xy equal to 0. The covariance is 0 means they are uncorrelated. When covariance is 0, obviously the correlation coefficient will be 0. Correlation coefficient is 0 means that is uncorrelated. So this part is 0 means this equal to 0, RHS is equal to 0. This will become E0 when this is equal to this one. So E of xy is equal to mu x into mu y. That is E of mu x is nothing but E of x and mu y is nothing but E of y. So you can write E of xy is equal to E of x into E of y only if it is uncorrelated. Similarly, there is a concept of orthogonal variables, that is E of xy is 0. So when the expectation of products of random variable becomes 0, then this is 0. So covariance of xy is equal to minus mu x into mu y. This condition is called orthogonality. And two variables are told to be independent. Expectation of x raised to m y raised to n is equal to expectation of x raised to m expectation of y raised to n. Now when you put m equal to 1 and n equal to 1, it will be expectation of xy is equal to expectation of x into expectation of y. This case comes, so independent means uncorrelated means it is independent, but when you substitute higher values for m and different values, it may not be an uncorrelated situation. So every uncorrelated is independent, but every independent is not uncorrelated. Moving to the next topic, that is what is bivariate transform. Suppose we have ignore this file. Suppose we have a bivariate random variable x and y and know their respective means and variance as well as their covariance, then that is, we know that the mu x mu y sigma x sigma y and covariance of x y are known. Then we can transform x and y to new set of variables u and v with a linear transformation, u equal to ax plus by and v equal to cx plus dy. So this is x and y are transformed to two variables u and v, because again we are discussing about bivariate, so there should be two new variables from the old variables. So that is why we have u as well as v. Now our job is to find the mean of u, mean of v. So we know that mu x, mu y, sigma x, sigma y, and covariance of x, y are given. This is the transformation. Then expectation of u is nothing but expectation of ax plus by. So move the expectation operator inside. So a into expectation of x plus b into expectation of y. So E of u is nothing but mu u is a into mu x plus b into mu y. So mean is linearly transformed, similar to u. So for v it will be the same as same case of u, that will be mu v is equal to c mu x plus d mu y. So we studied about how to identify the mean. Our next task is to find the variance. So we know that sigma u square will be expectation, or sigma x square is generally expectation of x minus mu x whole square. So sigma u square will be expectation of u minus mu u whole square. Now substitute for u. So what is u? U is nothing but ax plus by. What is mu u? Mu u we have found in the previous, that is au mu x plus b mu y. Substitute that here and that whole square. Now simplifying, so ax plus by, a mu x plus b mu y, a is ax and a mu x as a common a. So I am taking a outside, remaining is x minus mu x and mu x, and similarly the coefficient b is there for y and mu y. So y and mu y together, so b is taken outside, so a into x minus mu x and b into y minus mu y. So if you expand this one, this is let it be m, let it be n. So this is m plus n whole square. So m square plus 2mn plus n square. So that is nothing but a square. So here a square x minus mu x whole square plus 2ab x minus mu x into y minus mu y plus b square y minus mu y whole square. Now moving the expectation operator inside, I can take a outside, so that will be a square, then expectation of x minus mu x whole square plus 2ab expectation of x minus mu x y minus mu y plus b square is taken outside, so expectation of y minus mu y whole square. Now what is expectation of x minus mu x whole square? That will be sigma x square. What is x minus expectation of y minus mu y? That will be sigma y square. Then what is expectation of x minus mu x into y minus mu y? That is nothing but covariance of x y. So substituting this one, then sigma u square will be a square sigma x square 2ab into covariance of xy plus b square sigma y square. Then we can identify the value for sigma v square also. So using the same similar manner, so where a b are replaced with the c and d. So generalizing, the mean of u and v will be mu u equal to a mu x plus b mu y, mu v is equal to c mu x plus d mu y, sigma u square is equal to a square sigma x square plus 2ab covariance of xy plus b square sigma y square. In the same manner, sigma v square is equal to, instead of a we have c square sigma x square plus 2ab, instead of 2ab we have 2cd covariance of xy plus instead of b it is d, so d square sigma y square. So this is the summary chart from where we have transformed the mean and transformed the variance. Our next task is to find the covariance of. So covariance of x y is expectation of xy minus mu x mu y, we have studied that one. So similarly covariance of u v will be expectation of u v minus mu v mu u mu v. So u is ax plus by, v is cx plus dy, mu u is mu u is a mu x plus b mu y, and mu v is c mu x plus d mu y. So substituting those values, and I am expanding here a into c x square, a d xy, b c xy. So a d plus b c xy plus b d y square. Similarly here also a c mu x square, a d mu x mu y, b bc mu x mu y. So ad plus bc mu x mu y minus plus bd mu y whole square. So all things are minus, so I am putting individually, subtracting each elements. Now if you see here, this is AC, this is AC, and this one also AC. So I can take AC outside and move the expectation of operator inside to x square. So AC e of x square minus mu x square. So that is done. Then we have AD plus BC e of xy, which is having the same coefficient here also, AD plus BC mu x mu y. So AD plus BC e of xy minus mu x mu y. Similarly BD y square. So expectation, if you bring here, it will be expectation y square minus this is also having the same coefficient BD. So that is cancelled. So BD into e of, this is the simplification we will do. So after that, if you see here, expectation of x square minus mu x square, what is that? E of x square minus e of x whole square is nothing but sigma x square. So AC sigma x square. Now this is e of xy minus mu x mu y is nothing but covariance of xy, and this is expectation of y square minus mu y whole square, that is nothing but sigma y square. So substituting all these things, AC sigma x square plus AD plus BC into covariance of xy plus BD into sigma y square. So this is what we get. So we can say that covariance of UV is equal to AC sigma x square plus AD plus BC covariance of xy plus BD sigma y square. So that is the expression for covariance. Then the correlation coefficient is easy, rho uv will be covariance of uv divided by sigma u into sigma v. So we know the expression for all these terms, covariance, sigma, mu, in everything we have derived. So overall this is our summary. Mu u is equal to a mu x plus b mu y, mu v is equal to c mu x plus d mu y, and the expression for sigma u square and sigma v square, as well as the expression for covariance and correlation coefficient. So once it is done, we will see a problem. The variances of the zero mean random variable x and y are given as 7.05 and 5.36 respectively. Also the correlation coefficient for x and y is rho xy is equal to minus 0.48. The bivariate random variable u and v are obtained with the transformation from x. So u and v are bivariate, they are obtained by transforming x and y with this equation, that is 2x plus y and v is equal to x plus 2y. So we have to find the correlation coefficient rho uy. Now we'll analyze the question and find what and all things are given. So we want especially mu x, mu y, sigma x square, sigma y square, rho xy, a, b, c, d. If these parameters are there, we can find anything. So these are the important things we have to note down. So from the question, it is mentioned that zero mean random variable. So both x and y are zero mean, means its mean value is 0. So for y also the same case. Sorry for the delay. Better I will write here. So mu y is also 0. Then what about sigma x square? The variables variance is also given. It is 7.05 and sigma y square is given 5.36. So and rho xy is also given minus 0.48. Now what is A from this one? This is A, this is B, this is C, and this is D. So A is 2, B is 1, C is 1, and D is 2. A, B, C, D are nothing but the coefficient of x, y in U is A, B, and C, D are from the transformation V. So this is what we got. So given value mu x is 0, mu y is 0, sigma x square is 7.05, then obviously sigma x is the root of that 2.66. Similarly mu y is 0, sigma y square is 5.36, sigma y is then 2.32, and rho xy is also given minus 0. So A, B, C, D are 2, 1, 1, 2. Now we have to calculate rho xy. So rho xy is rho uv we have to find. So in order to find rho uv, we want covariance of uv. Covariance of uv requires covariance of xy also. So in the problem it is not given here. Covariance of xy is not given. Instead we have rho xy. So we can calculate covariance of xy is rho xy into sigma x sigma y. So rho xy minus 0.2.66, 2.32 gives minus 2.95. And sigma u square, we have to calculate sigma u square and sigma v square. So we know the expression of sigma u square as a square sigma x square to ab covariance of xy plus b square sigma y square. So same for sigma v also. So substituting those values here, sigma a square sigma x square plus 2ab covariance of xy plus b square sigma y square. So a square is 4, 7.05 plus 4 into minus 2.95 we calculated here, and b square is 1 into 5.36, so that will be 21.76, and sigma u square, sigma u will be 4.67. Similarly, sigma v square is c square sigma x square plus 2 ct covariance of xy plus d square sigma y square. So c is 1, t is 2. So substituting these values, we will get 16.69. So sigma v will be root of that one. The value will be 4.09. So once you get these values, we have covariance, we have sigma u, and we have sigma v. Then the next task is covariance of uv we have to find, because we have covariance of xy. For rho uv we want covariance of uv actually. So we have to find that using the expression covariance of uv is equal to ac sigma x square plus ad plus bc covariance of xy plus bd sigma y square. So if you substitute that one here, AC sigma x square plus AD plus BC covariance of xy plus BD sigma y square. So that is nothing but A into C is 2 into 7.05 plus 5 into covariance we have calculated in the here minus 2.95, then BD into sigma y square is 2.5.36. So if you get, you will get 10 point, substitute, you will get 10.07 as the value. Now if it is not, then rho uv is covariance of uv divided by sigma u into sigma v. So covariance of v is 10.07 and sigma u sigma v are calculated as 4.67 and 4.09. So that values are substituted here, you will get as 0.53. Now so rho uv is equal to 0.53. So what is our inference? Inference is that initially the x and y had a negative correlation. Negative correlation means x, if x is increasing, y is decreasing. or they had a value which is not correlated, not related. When it is transformed like this, what happened to the correlation is it becomes a positive correlation. So if two data are not related, we can relate them by using a linear transformation. Is that inference we have to get from this problem. So that's all about today's class. Thank you.